Alright, so this video is going to be part 2 of our infinite series practice, okay? So we have a question up on the board here. Is the series the sum from n equals 1 to infinity of 3 to the n plus 1 times 4 to the negative n convergent or divergent? If it's convergent, then we're going to find the sum. So this looks a lot like a geometric series. All we have to do is just kind of manipulate the exponents to make it a geometric series. Okay, so we start off with the sum from n equals 1 to infinity of 3 to the n plus 1, 4 to the negative n. Now we can rewrite this as the sum from 1 to infinity of 3 to the n plus 1 over 4 to the n. Because now we're dealing with two exponents that we can easily manipulate. With that negative n, there's not really too much that we could do. Okay? So we can write this again as, well, now let's try to mess with these exponents a little bit. If we were to divide this up, if we wanted to make this n minus 1, okay, then we would need to add 2, okay, because negative 1 plus 2 equals 1. So what we need to divide, or what we need to end up breaking up this exponent into, is a 3 squared times a 3 to the n minus 1. Okay, that's how we get our n minus 1. We divide by, well, we need to get an n minus 1 out of this 4 to the n, and how we do that is just by pulling out a 4, okay, that's 4 to the first power, and on the inside we have a 4 to the n minus 1. Now if we were to multiply this through, okay, we have a 1 here, you can kind of think of it like that, and, well, when we multiply these through, we add the exponents, we get our n back. Okay, so, well, all we have to do now is just make this a little prettier. We get the sum from n equals 1 to infinity of 9 over 4 times 3 over 4 to the n minus 1. Alright, and, well, 3 over 4, well, that's less than 1, and it's also greater than negative 1. So that tells us, since you could say, I guess, since 3 over 4 is greater than negative 1 and less than 1, we know this series is convergent. So now we just have to find the sum. Okay, and how we do that? Well, we're just going to use that formula a over 1 minus r. What's our a? That's 9 over 4. And what is our r? That's 3 over 4. Okay? Alright, well, 1 minus 3 over 4, that's just going to be 1 over 4. So we get a 9 over 4 minus 1 over, or divided by 1 over 4. Now the 4's go away, and you're just left with 9. And that is your sum. Now we have our next problem up on the board here. We want to see if the series n equals 1 to infinity of 1 over 6 plus e to the negative n is convergent or divergent. Okay? Of course, as always, if it's convergent, we want to find the sum. Now, this series, it honestly looks like it's baiting you to possibly try something with a geometric series, okay? Because we have a negative n, we have an n in the exponent, okay? But that's going to be really, really hard because we have it in a fraction and it's added to something. Okay, so yeah, it doesn't look like we're really going to be able to do that here, okay? But what we can do is just try to use the test for divergence, okay? And if we do that, we take the limit as n approaches infinity, well, that's of 1 over 6 plus e to the negative n. And, well, how can we rewrite e to the negative n? Because it's kind of confusing. We have n approaching infinity and we have a negative n here. So what we can do is rewrite this as 1 over e to the n. Might just make it a little bit clearer for you. If you can already see it, then that's fine. And as n approaches infinity, this is just going to get larger and larger and larger. So this will go to 0. And you're left with 1 over 6, which is not equal to 0. And that means that this diverges. So we have our last problem up on the board here. It's the same problem, but now we have the sum from n equals 1 to infinity of natural log of n squared plus 1 over 3n squared plus 5. Okay, so here, well, we don't really have a p-series. We definitely don't have a geometric series, okay? So, and of course we have that natural log here. So the only thing we can really do now is do the test for divergence, okay? We take the limit as n approaches infinity, and we have the natural log of n squared plus 1 over 3n squared plus 5. Okay, and as it sits right now, you would get natural log of infinity over infinity. Okay, that's not really going to work. What we can do is just divide every term inside here by n squared, and this will start to become a lot clearer. We get the limit as n approaches infinity of the natural log of 1 plus 1 over n squared over 3 plus 5 over n squared. And now it becomes a lot simpler to see what's going on here. You know that this 1 plus n squared goes to 0, 5 over n squared goes to 0, and we're left with the natural log of 1/3, which is not equal to 0, and that means that this series diverges. And that's going to do it for this video.
So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for sequences in series and the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.